For the last 30 years, Egyptian archaeologist Fakhri Hassan has been looking for his own explanation of why Egypt turned from stability to chaos.
I felt compelled to find out why did it happen when it did, especially when Egypt was doing so well, when we had the pyramids, when we had temples, when we had the statues, when we had major achievements in arts, literature, and everything else. Why did it end at that time? And so I had to pursue that question. I had to find out for myself the reasons for the sudden and unprecedented collapse of the Old Kingdom.
Fakhri Hassan has always challenged orthodoxy. The conventional wisdom is that the Old Kingdom fell apart after the death of a pharaoh, and the battle for succession caused a major political conflict. For Fakhri, this just didn't ring true. The first seed of doubt was planted in 1971, when Fakhri found evidence of something far more devastating than political unrest. This little-known tomb in southern Egypt has an astonishing story to tell. The tomb belongs not to a pharaoh, but to a local governor called Ankh-Tifi, who lived just after the collapse of the Old Kingdom.
For me personally, it's an incredible find. This is a remarkable tomb. This is one of the most outstanding tombs in all of Egypt.
It's in Ankh-Tifi's writings that Fakhri found the vital clue. The hieroglyphs tell of horrendous famines and the sufferings of ordinary people.
It is rarely that we have a voice from the past that gives us a poignant account of what has happened, of the horrors, the famines that happened 4,000 years ago. And to have them reported in such a concise and clear fashion is unprecedented.
The entire country has become like a starved grasshopper. I managed it that no one died of hunger.
One small section is particularly moving. It tells of the despair and the atrocities during the famines which were ravaging the south of Egypt. For Fakhri, the writing on the wall was far too powerful to be ignored. In these caves, Mira Bar Matthews has found a unique record of past climates. All the water here comes from rainfall. As the rain filters down through the rock, it dissolves the limestone, forming stalactites and stalagmites. And as these gradually build up over the years, they trap ancient rainwater. Mira has discovered a way of calculating rainfall thousands of years ago by taking tiny samples of the stalactites. The ancient rain contains two different types of oxygen, a light one and a heavier one. If there is more of the light type, it was a very wet period. More of the heavy one means it was dry. Analysing the samples in a mass spectrometer gives the ratio of light and heavy oxygen. Mira had been analysing stalactites stretching back over thousands of years when she got to one sample 4,200 years old. As soon as she saw the results, she knew something unusual had happened.
The striking finding was that there is a very important change in the amount of rainfall that was in this area.
Mira had found a staggering 20% drop in rainfall. This suggested a sudden and significant climate change.
This drop is dramatic. This event is the largest event over the last 5,000 years.
Even though Egypt and Israel have different weather systems, this finding was very exciting. Rapid climate change was the culprit Fekri had been searching for. He believed it was the prime suspect in the catastrophe that destroyed the Old Kingdom. The reason why this powerful civilization disintegrated at the height of its glory.
I firmly believe that in addition to gradual changes on millennial scale, climatic change can also happen very, very rapidly, suddenly, and swiftly with dramatic consequences for people. But because abrupt climatic events happen very rapidly, within a few decades, they can influence the livelihood of people, causing famines and droughts. They are of such magnitude and of such rapidity that people cannot deal with them in the way they would deal with a protracted long-term climatic change.
The bogs of Ireland. Slices of trees from these bogs contain a record of climate stretching back over 7,000 years. Each year, the trees put on a ring of growth. During the good years, those growth rings are thick. In bad years, so small they can be hard to measure. When Mike Bailey measured the tree rings in one particular sample, something made him sit up and take notice.
This is a piece of Irish oak. It grew for about 300 years and then was buried in a peat bog and has survived to the present time. It was actually growing about 3,500 years ago. Now my interest in this is that when you look at the exactly dated rings across this period, we find that the tree has been growing quite well up until 1628 BC, which is this ring, and 1627 there's no summer growth, nor in 1626, nor for about 10 years thereafter. And these are the narrowest rings in the entire life of this tree, and clearly it's the worst growth conditions that this tree had seen in its lifetime. The trees can't tell us exactly what happened, but the logic is that they were probably responding to increased coldness or increased wetness, or possibly both. And the thing about wetness on a peat bog is that if you raise the amount of water in the peat, raise the water table, you're likely to cover up the roots of the trees and affect them in that way. So I certainly became interested in whether this environmental downturn, probably involving cold and wet, was due to the eruption of Thera.
Absolute proof that the Irish oak trees were stunted by the eruption of Thera has just been reported from one of the most desolate parts of the world. The ice sheets of Greenland have built up over thousands of years from annual layers of snow. As the snow falls, anything lingering in the atmosphere is swept up and locked into the ice. Sulfur from volcanic eruptions is trapped as sulfuric acid. The snow that fell 3,500 years ago is now over 700 meters deep. When Danish scientists tested the ice at that level, they found a layer of sulfuric acid. Embedded in that acid layer were tiny shards of volcanic ash. The shards have just been chemically fingerprinted. The unpublished results have convinced the scientists that the ash came from Thera.
I mean, it's fantastic news because what it gives us is the final link in the chain. What you've got is Thera linked to the acid in Greenland. The acid in Greenland is occurring at exactly the same time as this reduced growth in the Irish trees. So what you're seeing here are the direct environmental consequences of the eruption of Thera. And that is fantastic.
The waves can travel thousands of kilometers across oceans. When they hit land, the results can be cataclysmic, as they were a century ago in Southeast Asia.
Krakatau in Indonesia, 1883. 36,000 people killed by an eruption that was far less in intensity, less than half the intensity of this eruption here. Those people were killed by tsunamis. This means then that we should perhaps be looking for tsunami deposits here, deposits left by these large waves.
Evidence of those deposits has eluded archaeologists for decades. Now Floyd has heard of an intriguing find that just might be what he's looking for. In 1997, a team of geologists came to this saltwater marsh. They drilled deep down into the ground and removed a core of mud. Back at a laboratory in Britain, one of the team started sifting through the core. After months of patient work, Dale Domini Howes found what he was looking for: tiny fossilized shells called forams.
And forams are actually very helpful to us because they live in a whole range of different environmental settings. Some like living in very shallow marine conditions, like on marshes. Others prefer to live in estuaries, and some in much deeper water. They're actually very useful because each individual species looks very different.
Under the microscope, the difference between the shells becomes clear. The one on the right once lived in shallow water. The one on the left originally lived in very deep water. As Dale examined the mud core more closely, he found something very peculiar.
As you go down through the core, you're going back in time. And all through the larger part of the core, we're finding absolutely no forams at all. When you get to this point, something very exciting happens. There's a very thin band or layer of sand, and this sand is absolutely stuffed with marine forams. This type of forams found in the layer are fully marine and come from much deeper water offshore. This means something very unusual happened here. A very unusual, high-energy event that's brought these deep water species from offshore into the marsh. So I suspect that this is actually the signature of a tsunami that's flooded into the marsh.
Dale's evidence suggests the volcano on Thera produced waves that travelled 100 kilometres across the open sea. Their effect would have been felt right along the northern coast of Crete, but most of all at harbour towns like Palekastro.
20.25, 19.87, 1, 15, 1.5, 18.75.
Much to his delight, Mexico's meticulous weather records
13,
revealed just what he'd hoped to
14,
find.
6.25, 89.62, 7.
It turns out that in the last century there was one severe drought. It was really a pretty bad drought. In fact, it happened in 1902, 1903, and 1904. And given the fact that really severe drought is so rare, we're really pretty lucky that it showed up in this 100-year record that we have here.
A drought that lasted 3 years proved to Dick that severe droughts not only could happen, but had happened.
This was certainly a very extraordinary moment. I hoped maybe if a pretty bad drought happened at least once, maybe it happened twice, and maybe that other time was when the Maya disappeared.
But one destructive drought in the last 100 years was not enough to hang a whole theory on. He had to search further back in time. To delve more deeply into Mexican history, Dick had to visit a most unlikely place, the city prison. Now the National Archives, it houses a unique collection of handwritten books, some dating back to the 16th century.
The land was everywhere dry and bad. Thus began the 5 years during which there was nothing to eat. The deadly hunger continued. People fell dead by the roadside. There was no water in the wells.
After months of searching, Dick found a number of haunting accounts of devastating droughts from the Yucatan province of Mexico, the heartland of the ancient Maya.
Great drought. The entire forest was burned, and the forest died. That which came was a drought, when the wounds of the animals were burnt. When the seashore burned, a sea of misery. They shall eat trees and rocks, as they shall be dying of starvation. Seated on their beds,
These reports that are contained in these books here are reports made by the Spanish colonial authorities to their superiors in Mexico City or in Madrid. And this one, for example, that I found is a plea for help from the authorities in Yucatan. The crops had been very bad in the year 1795. They were running out of grain, and they were very much afraid that the terrible death that they had seen so often in the past was going to repeat itself again. So they say, send help now.
Dick was now certain that he was on the right track.
If we walked outside right now, we'd be able to tell that it was cloudy. We would be able to tell that it was cool and that there wasn't a great deal of wind. But we wouldn't know about the greenhouse gas content. We wouldn't know if it was stormy out in the oceans. We wouldn't be able to tell as richly what we can tell from the ice core record going back through time. And that's a pretty odd thought when you think about it. We've captured something that's almost better at telling us about the past than we're able to tell by going out sniffing the air outside.
Paul has constructed a uniquely accurate history of global weather from his ice cores. When he heard about Dick's drought theory, he decided to check his cores for the 9th century. Would he be able to find any evidence of dramatic climate change in the Northern Hemisphere?
First thing that we looked at was our record of ammonium. And ammonium is a chemical that gets up into the atmosphere, which tell us whether or not there was a lot of vegetation in the Northern Hemisphere. If there's a lot of vegetation, one assumes it was probably warm and wet. Low amounts, that it was probably drought conditions, that there weren't a lot of plants, the soils had probably dried up.
And when he looked at the ice that was 1,200 years old, he was astonished.
We found that there was a tremendous drop in ammonium. They, in fact, had probably not experienced a drought like this going back 2, maybe 3,000 years.
So the ice cores confirmed Dick's hunch. At exactly the time of the Maya collapse, it was dry and cold across the northern hemisphere, the very conditions that would indicate drought in the Maya areas. But archaeologists remained unconvinced. If there had been such a severe drought, why was there no record of it in the Maya's own chronicles? The Maya carvings tell of great battles, of ruling dynasties and all-powerful gods. But on drought, they are silent.
I decided to see whether the Maya had written anything about drought. We don't find anything on their monuments and buildings, but I thought that if drought were a regular part of Maya life, that they must have written about it somewhere.
Then he had a stroke of luck. He came across this rare manuscript written by the Maya, one of the few that had not been destroyed by the Spaniards.
So I came to this Maya book to see whether there was any discussion of drought. And right here on the last page, there it is. There is a hieroglyphic symbol for drought. They did write about drought. It was an ongoing part of their life, and there it is right there.